All right. Good morning or good afternoon or good evening, depending on where you're joining us from today. This is the Grand Challenge Breakout session focused on digital twins. Just a couple of reminders, the session is being recorded and your participation in the discussion is your consent to the recording. Feel free to take yourself off mute. Everyone was muted upon entry, but jump in on the conversation, take yourself off mute. And you can also do so by using chat, dropping in notes there as well. We'll be reviewing that throughout the discussion. At this time, I'd like to turn it over to Mr. Bobby Noble, who's going to lead the discussion for us today.
Excellent. Well, thank you everyone for joining. And I know we still have folks logging in as we're just at the bottom of the hour here at 10:30 a.m. Eastern. And so I'm glad to have each of you on as we're looking at this Grand Challenge breakout session on digital twins. A little bit of background on myself. If you were not on the other day, I'm Bobby Noble. I'm the program manager for our gas turbine programs here at EPRI. So in generation, it's program 216, the gas turbine life cycle management, and also program 217, the gas turbine advanced components and technologies. And so I'm, have extensive work with digital twins for gas turbines for several years and was excited to be with you on Tuesday. I know that we also have one of my co-speakers, Wesley Bausch from Southern Company, has just logged on as well. And so Josh Berry from TVA has a conflict for today and will not be able to join us on this session, but at least we have two of our three panelists from Tuesday, and so we look forward to having the discussion. And again, I know as folks start to log in, we'll maybe repeat a few of these things for folks, but let me click on the correct screen so we can advance the slide. So with this Grand Challenge, what are we looking at? Well, we're looking at trying to identify top challenges in the energy industry associated with digital twins, specifically thinking where AI, machine learning intersect with these opportunities. And so again, as Anshu had mentioned, you're more than welcome to unmute yourselves, and you can audibly ask questions or make comments, but you can also utilize the chat feature. And one thing I do want to remind everyone, and apparently this is an ongoing issue right now with WebEx, make sure that when you are putting in your chat, just double check that everyone is chosen in the to field. That way that everyone on the call can see the comment that you're making. And so one of the challenges, I think, is WebEx is having a little bit of a bug right now with resetting that to going to other folks. So just keep that in mind. Make sure everyone is selected, and then that way, one, that I'll make sure to see it. And if it by chance goes to the host, Anshu will make sure to send those to me. So we'll make sure to capture those comments and questions and address them as best as possible. With that, Wesley, I do want to maybe put you on the spot. I don't know if you have any comments or thoughts as we start for this morning.
Hey, Bobby. Good morning. No. I just thanks for the introduction and getting us started today. No, I just wanted to say I appreciate the time on Monday to present out on this and look forward to some continued discussion on it. The biggest challenge for me from innovation is always, again, finding people that can work with us, and then of course on the backside it's always finding a landing spot for it. I always refer to it as sponsorship. So as we talk through thinking about what functional area or what group within Southern Nuclear would be the person that would have the authority and of course the funding to back up a project in digital twin. But my job is primarily to bring the ideas to the table or address concerns from within and find solutions for people. So it's, again, with digital twins, it's been both sides of things. I've been trying to keep us engaged with as many things that are out there already, and have had some input from within the fleet looking for solutions in this area. So I appreciate it, Bobby.
Excellent. Well, thank you, Wesley. First of all, you gingerly corrected me there. I accidentally earlier said that we had our session on Tuesday. It was actually Monday. I think this week has been has all been mixed together. So if you're thinking I didn't watch that on Tuesday, you're right. We had that session on Monday. And really, from your background, I think that's what we're asking for everybody on the session today, is not necessarily thinking about the mechanics of how these solutions can be implemented, but really trying to give ideas for what could be done. Let's not completely think about the possibilities of how we get data. You know, maybe there's challenges or discussions there that we do need to address, but let's throw out ideas. Let's have discussions that are challenging, and that, you know, maybe we're going to take a lot of work and a lot of coordination, but that's okay. That's what we're here for. And so as we move in, again, for those that just joined in, I want to remind you, feel free to put in comments in the chat. Make sure that the everyone listing in the to is selected before you hit enter. That way that everyone on the call sees that. You're also more than welcome to unmute yourself, as everyone came in muted. Just like Wesley just did, you can unmute yourself and we can have verbal discussions as well. So just to give everybody a quick summary of what we talked about on Monday in our session. You know, we had a couple themes, and we had some very complementary but yet different themes as we looked through each of the presentations. And so as I started out talking about digital twins for gas turbines, and really thinking about the asset itself and how we're working here at EPRI to combine unit physics with the analytical model aspect and utilizing artificial intelligence and machine learning where possible. And I threw out a couple things, one that we're working on, and another as far as an idea that we would like to look at, but looking at, first of all, advising maintenance schedules or practices. And specifically, we got an example of gas turbine compressor water wash, and looking at predictions there. And then another idea was around trying to take your APR software and, you know, the challenges around having to continually retrain those models. Can we actually use digital twin to forward feed information so that you don't have to do that? And then Wesley came in and gave some perspective from the nuclear side, specifically looking at Southern Nuclear and looking at asset and operational digital twins. And so some examples that he gave around plant chemistry management, so the system unit twin, steam generator integrity, so kind of the asset twin, and then the process twin with thinking about virtual reality training. And so those are some good topics that Wesley brought up on Monday. And then Josh Berry from TVA brought up around enterprise data governance and enablement. And so this is a huge issue, no matter which sector of the energy industry you're in, that, you know, how do we get data? Who owns it? How can we share it? How can we best utilize it? And really, how does the digital twin, you know, how do we fit it in, and what are the pathways that are needed? And so just wanted to kind of remind everybody of some of the things that we've talked about already this week as we frame our discussion today. And so with this, I do want to shift us over to start the discussion. And as far as, you know, some questions to think about, do you feel any of the reverse pitch themes are already solved? Is there an existing technology or research that addresses them? And so I don't know if anybody, I'll pause a minute to see if anybody has either comments for the chat or if anybody would like to make any comments around verbally around this question.
Bobby, this is Lalita Utpa. I have a comment or question for Wesley. You know, I have been working with EPRI SGMP on two projects that I presented. One was it's basically related to the steam generator unit. One is on the integrity assessment part where we developed a a standalone module that can take the eddy current probe signals and predict or determine the anomaly degradation mechanism and even profile it and all that. And we also worked on simulating this eddy current inspection process and for different commercial probes. Now, I am a little, this term digital twin is something of recent vintage. So I wanted to ask Wesley, what would be the full definition or description of the steam generator integrity or asset twin, or the terminology that's used? Can I get some more clarification there?
Yeah, and I think we're thanks for the question. I think we're really at the early stage of that discussion, and this was something that again, 50% of my job is reaching out when I hear with the ear to the ground, hear something that's going on in the industry, and I'm also Southern Nuclear's NMET, so when I see an opportunity for collaboration, it's kind of my job, whether it's me or one of our EPRI advisors, to make that connection. So in this case, last year when I reached out to Jeremy Renshaw and heard about some areas where they were starting to look at possible digital twin solutions in areas that we haven't looked at before, that steam generators came up, and considering I've spent my previous 12 years before last March in chemistry, and a lot of that on secondary chemistry, I knew who to reach out to and get that discussion going. So I've really just been tapped into the process that Brett Capel at EPRI is leading. And really at this point, the discussions we had were really trying to focus in on exactly what we want the digital twin, what area we want to look at first and foremost. And what I got out of the last discussion I had with Brett is, again, leaning toward what we could get out of a digital twin for predictive analysis of tube life. What could we use a digital twin model to plug in all this historical data and kind of give us a better idea of tube life based on stress corrosion cracking history and history on certain steam generators and the like. So I think that's where that group appears to be leaning at this time, compared to maybe a digital twin on, again, like the steam transportation or hideout return. Some of the other things I mentioned on Monday, I think would be great things to kind of model in a digital twin. But I think right now the thing that appeared to be most beneficial to the SGMP is creating something around that helps out the engineers on the tube life analysis side of things.
Okay. So
excellent.
If I understand correctly, the end goal, the most critical thing is to be able to predict the remaining useful life of the tube and move to a condition-based predictive maintenance kind of thing, concepts.
That is a great way to summarize it. I would agree with that. Yes, yeah, because part of that strategy is definitely going to be the maintenance portion of it. And this is all, and I think Brett even said for bad reasons probably, that one of our plants, Vogel, is a great candidate for that because of some of the history of issues we've had with that. But our steam generators are doing really well right there, are at Vogel now, but they're original 600 TT generators. So the whole point is, there's plenty of plants out there that are kind of in similar boats, if not the same boat. And how could we use a digital twin model to help exactly do what you said, help us better maintain them so that we can get them to last the life of the plant? Because at this point, replacing steam generators is a challenge for any nuclear fleet. So it's how can we use a model to really get us to the life of the plant on those generators.
Okay, great. Thank you very much. Yep.
Excellent. Well, great discussion there. I know it looks like Rajesh has a question that he just put in the chat a couple moments ago about what would a digital twin require to achieve for behind the meter distributed energy. And I think that's definitely a challenging discussion there. Wesley, maybe I'll make a couple comments and then maybe you can give some thoughts as well. But part of this brings into thoughts around Josh's comments or his presentation from Monday, looking at just how to get data, because part of it is, when you look at behind the meter distributed energy, that's starting to become a challenge with being able to access data. There's potential privacy issues and other aspects. And there's a whole lot of unknowns when it comes to this distributed energy network, if you will, for how the digital twins would be able to at least access data. Maybe the assets themselves potentially are maybe easier to model than some of the big generation assets like nuclear and gas turbines and so forth. But I think, you know, really one of the biggest challenges would be the data interface. I don't know, Wesley, do you have any thoughts around that question? I know that's kind of out of both of our fields to some extent.
It is, but I know that's a challenge again on the back end we need to think about, especially in the nuclear side of things, because it's always a challenge to set up data sharing. I mean, we have numerous NDAs and stuff of that nature set up with EPRI so that we can do that, like chemistry. We just had a large one set up for data analytics, any project related to that we're working on with you guys. You know, just to get back to the question, I think as far as what research projects does EPRI need to deliver, I think for us, you know, just having that collaboration, knowing that we have kind of open data sharing with EPRI and being able to pilot something, I think that's really what, in the case of the SGMP, and same thing goes for the chemistry related, the plant chemistry database update that David Perkins is working on. I think they're, you know, I raise my hand to say, hey, we want to be the beta tester on that. We want to be, if you need someone's data, we want to be that person so that we can, you know, one, be at the forefront of the work that's going on in this area, but two, you know, lead by example and show that, hey, this worked for us, it could work for you. But that what is mentioned in the chat is definitely a challenge, because you're right. If something comes up around a steam generator, not everyone has that same Westinghouse, I think, what is it, Westinghouse 52F, I don't remember the number. I've been out of chemistry a little while now, but that model of steam generator that's used at Vogtle. So you're right, what EPRI will have to end up kind of producing is something that's specific, but in a model that can be shaped well enough to fit all the other plants in the fleet.
Yeah, absolutely. And, you know, and if there's other thoughts, I think this is definitely something that we can add to that list of how is this being addressed, what work needs to be done there. And then, you know, Kelly brings up a great point as well. And I'm trying to work on getting some links put in the chat here. But given that any digital twin is likely very site specific, what research products does EPRI need to deliver to enable digital twins, aside from sharing information about what others are doing? And I think this is, you know, a big differentiation that has to occur. I know specifically I can talk about our digital twin work within the gas turbine program. That's one reason why we are developing our digital twins from the ground up. And ultimately thinking here that we want to be able to give, you know, the industry a way to, one, know exactly what your digital twin's doing. Two, trying to make sure that you can make adjustments or replicate. And so, you know, at this point, we have developed it, and we've talked about, you know, how this development works. We are working on making a platform so that in our case, you can take, you know, this specific type of unit asset that has a generic twin, and then look to implement that or replicate it on your own for other units, so that you can kind of do these things on your own. So I'll put in a product ID number. Actually, maybe I can get Unchu to help me get the actual link. I'll give her the product number here so that we can put this in there. You can take a look at it, and if you've got questions, you can always contact me or Jeremy, and we can have further discussion or look at how we can work there further. Wesley, I think you probably would have very similar, you know, thoughts or comments there, that we really have to be careful and know what our digital twins are doing, because if you just take a generic, software from a third party or OEM company, you don't necessarily know what it's doing. It doesn't make it bad, but maybe it doesn't do what you need it to do. So I don't know, Wesley, any thoughts there?
Yeah, and I'm sorry that my last response, I probably answered Kelly's question more than Rajesh's question, but so back to his just real quick, that's kind of out of my realm as far as the behind the meter distributed energy. That's more on the power delivery side of things, but I agree, it's just a matter of setting up that ability to openly transfer that data. But back to what you just asked, Bobby. It's 100% a challenge. The weird thing about it is, first, it's something as simple as we're looking at an innovation, analog gauge readers that we're planning to install, starting with Farley Nuclear Power Plant. And again, that's so we don't have to do these huge, crazy engineering, modification processes that are very costly and take a lot of time. What could we do in the interim to kind of help us out, better monitor things in the field where there are analog gauges, and it requires pretty much someone walking down that area all the time. But even in that case, that last threshold, so it's one thing to get a network set up and get that information going, similar to like a digital twin. It's one thing to set up a digital twin and have the capability to plug data into it. The backside of it is whether or not we can use that for operational decision making, and that's going to be the biggest challenge. Like I said, whether it's a analog gauge reader, it's great that we can now feed that data in, every, let's say, minute to a data historian, but trend it better and have more predictability if we tie it into AI type of technology or machine learning. But are we as a nuclear industry ready to say, okay, well, an operator in the control room can make a decision based upon the data they're seeing there, rather than going down and physically seeing what's going on the gauge. So that's kind of that really is the biggest challenge with any of these, and I think that kind of hints at what you were getting at, Bobby. If not, let me know and I'll elaborate.
No, I think that's perfect, and it kind of actually, I think, will lead into couple other questions that specifically I think are maybe well, I know one's directed for you, but the other I think kind of is as well. So we've got one question: a forward-looking concept, a detailed, comprehensive nuclear unit digital twin would be able to focus the operators and leadership on degradation issues that are likely to become the most consequential and potentially be used to inform the station work schedule. And then I'll add in the other question for Wesley from an remaining useful life RUL prediction standpoint. Is Southern Nuclear's focus just on steam generators at this time, or is there interest in doing this for other types of nuclear assets as well?
Well, I definitely think I can answer those in one response, Bobby, and the answer is yes. I mean, really, our look at even digital twins, I've only been in this group for about 14 months now, but it really started last year, maybe fall of last year, of saying, hey, this is something that we want to start looking at and figuring out where our place is in it. So the only reason I use steam generators outside of being near and dear to my heart from my chemistry background is that's just where, when I started to do my research and reach out, of course, I'm going to start with EPRI. I'm going to start with other vendors that I know that the nuclear industry is very familiar with, and see what things they are proposing. So that's where we started. I knew that, I reached out, and that just happened to be one thing that I knew EPRI was starting to get a team around planning. So no, I think we're open to anything at this point. I think a global type of comprehensive nuclear unit digital twin is great. I know there's a company actually in the last week, a vendor that reached out to me about something similar. Look at that without many specifics before I meet with them. But yes, I think anywhere where it could help, I want to be the person to bring it to that work group. Like I said, in the end, the only challenge with me from innovation is I'm not that sponsor in the end. So it's being able to shape something to present back to a specific working group and say, hey, this is something they could support us on. Is this something that you would be willing to sponsor and get behind? But but yeah, at this time, we're really open to wherever this journey takes us.
Absolutely. Well, Jose 258 has mentioned that he wants to make some comments, so feel free to take the floor.
All right. So for a number of years, North Anna has been providing data to a project out of Oregon National Labs associated with LPI to do a physics-based digital model for their high-pressure feed water system. Of course, any kind of digital twin requires data. And so one of the things we identified relatively early on is that there's a limitation on the current available data. So, we've made some adjustments, but their goal, the Oregon National Lab goal, is to create a piece of software that using your PNIDs and component information, you can create a digital twin of any power plant system. And so the initial work began with high pressure feed water. There is work currently ongoing to develop a grant to do larger scale project and to implement that at a nuclear utility. That grant is going for review here in the next month or so during the next grant cycle. But the early data indicates that it's doable, that they were able to create a high pressure feed water model that was able to mimic data response that we were seeing from the station. I tell you, the hard thing, of course, is just getting the data to them, and you need lots and lots of data. But we are working our way through that. But certainly there's interest in getting other folks involved in doing that digital twin work and creating the software package for it.
Oh, that sounds great. Thanks for sharing that. And having worked for Dominion before I came to Southern at Kewanee Nuclear Power Station, before the little plant that could was closed down. I'm familiar with some people there, and that's great that they're supporting that effort too. I definitely, I'm sure we're not the only ones that could see massive value in this. And you're right. I don't think we want to limit it to a particular asset or system in the plant. If there's people out there that can design software around it, figure out what area it may be most important for us at Southern Nuclear and go from there.
Yep, I agree.
No, that's a great comment. And one of the challenges, and I'll kind of add this as a thought with that. So, in generation, we've done a lot of work trying to look through various AI machine learning capabilities to try to look at fault identification in data from gas turbines specifically. And one of the challenges that we have found is that when you have a system that has so many, well, really you have holes in the data. First of all, a gas turbine, if you're not familiar, essentially only has enough data points to operate the unit. And so really it's not so much that the sensors are there for understanding health or either debugging what's going on with the unit, but more so just the minimum amount to make the control system work. And so, criticality is not quite the same as maybe in a nuclear setting or some other assets. So one of the challenges we've had is fully data-driven approaches tend to fall short because there's failures that in the sensors look like a dirty compressor and a fully damaged compressor look the same from a data signature standpoint. And so one of the challenges we've tried to look at and have not really need further investigation is how do we simulate or emulate failures that maybe there's no data for. Specifically, you may not have seen this particular type of failure at your plant, and that data does not exist to you. maybe there's not a proper data set for the entire industry even available for that type of failure. So how do we simulate that? But then adding to that, simulated data sometimes is too clean to actually properly use in other software. So I don't know if anybody has thoughts or comments around that challenge.
I've thought a lot about how we learn equipment failure. And the thing that I kind of pause on is that we have a wealth of data that's available to us in our history. The trick is to be able to extract that from the data warehouses that we have for events and at least have an idea of what the precursors we could see with the instrumentation that we have. It gives us a starting point. But to go out and look for where did you have a particular failure, use the industry data so that we all learn about what are the things to look for in preparation of a failure. I mean, it's out there. You got to find that gold in the data, and there's just a ton of it.
Well, I would even challenge the thought that it's fully out there. I know that for gas turbines, for example, that compressor surge and stall is potentially a problem. The challenge is the compressor is not well instrumented, and so while there may be instances out there, you again may not have data available to show the occurrence, and so it's just a challenge for us to think about how do we overcome that. Is the only way to overcome it adding more instrumentation, or is there other ways?
Certainly, we don't know what the data will show us, but it's worth going to look and see if there was something that we didn't realize was a predictor of performance.
Correct. Yep. So I know we have one other comment in the chat around that there's digital twin and virtual reality twin that gets updated with design changes in real time. And so that's definitely something that I think is important. I know that that's something with the EPRI gas turbine digital twin that at least conditionally the unit kind of self-updates. It will take time to essentially relearn if there's hardware changes, but having some sort of self-learning aspect, I think, is very critical to a useful digital twin or VR twin. Wesley, any thoughts around that?
No, just the same thought I had earlier. I mean, we set up a measuring and diagnostic center for Southern Nuclear specific. Southern Company had one, but we really didn't. Not with nuclear, people with nuclear background. So we've set that up over the last year and a half, and that was part of moving to a fleet-wide data historian. And we're installing a ton of things to bring more and more data into that. But it's the same. I think the same comment I had earlier. It's one thing to bring it in. It's another to make operational decisions on it. But I'll tell you one thing. They're challenging. It seems at least once a week on morning calls for the sites to utilize the functionality of all that information, whether it's new or old, coming into the M&D center to keep an eye on things, to understand how what's going on in the plant and at least help drive what decisions are going to be made. So yes, it's very important for us to keep going in that direction, adding things that bring in more data to a centralized location, and being able to do something like this would be the same thing.
Yep. Well, and I think the comment here, and this was discussed a good bit on Monday's session as well, but a crucial aspect of digital twin is validation and verification. Any thoughts? My thought is absolutely 100% true there. If we're going to make actionable items or actionable things, and for these crucial assets, we've got to make sure that we're certain that the data is telling us what we think it is. And I think one of those aspects is building in insights to ensure that sensors, for example, are reading properly. Wesley, any other aspects or thoughts that you want to add there?
No, I think I agree with you 100%. I mean, that is definitely going to be an important part of trying to go from, piloting something to actually implementing it, whether it's at an asset level or a system level. If we're gonna spend the money and effort to really work on something, that has to be part of the early conversation for sure.
Absolutely. Well, I see on the participant list that Gregory has raised his hand. Go ahead, unmute yourself, Gregory, and feel free to share with us.
Yeah, it's interesting that the topic of V&V was brought up with respect to the question that you were mentioning earlier about lack of failure data, or at least lack of high fidelity enough data with which we can emulate degradation and therefore diagnose and prognosticate remaining life and so on. I mean, to me, like your earlier question does boil down to a question of V&V. So if we want to be able to take some combination of data-driven approaches and simulations of the relevant phenomena, we need to go through the difficult exercise of identifying those phenomena that are contributing to the degradation, and to be developing our simulations in a manner that is indeed valid. I think it is sometimes tempting to simply do a curve fit and fool ourselves into thinking that a curve fit is credible. But I think in a lot of situations, it is truly warranted for us to actually like quantitatively demonstrate that we can be using these digital twins to represent reality through operational data, experimental data, and so on. And I think in so doing, we can then move forward in a trustworthy sense. Like, trustworthiness in AI has become kind of a buzzword. Like, I think that really is what we need to be demonstrating whenever it comes to our development and deployment of digital twins. So I guess I agree that's an open research topic. We need to be doing work there.
Yeah, that's a great comment, and really important. And maybe that's one of our grand challenges is developing a methodology for how we validate. Maybe there's some standard that's needed because you're right. I mean, a broke clock is right twice a day. We need to make sure that, first of all, we're not haphazardly picking out something that we think is there just because it fits the narrative that we're hoping for or looking for. But then also, as we try to get, part of making these tools, I think, is ultimately speeding up the M&D process. So if I can have the computer tell me exactly what's going on with my asset, then that frees my time up to do other things as an M&D analyst or other SME that's involved with the asset. And so if you're getting bad advice there, essentially it does you no good. And so I think that is definitely a key challenge and aspect of validating. So I would, as we're continuing this conversation, I love the pathway we're going. I would like for everybody on here, if you could think about 1, 2, or 3 big challenges that are facing utility participants today that digital twins could help with. Maybe there's comments that you can make, if there's a topic or whatever else, please go ahead and put those in the chat. And Gregory, you pointed out here standards development perspective on digital twins. ASME Verification and Validation Standards Committee are actively writing this up. Forthcoming standard number will be V&V 70. And so that's great for us to take a look at. And is that general standard good enough for everybody? And so maybe that's the next step of taking that standard and seeing if it's needed to go further. A comment here for AI Digital Twin. It's like, do not trust and verify, rather trust but verify. Absolutely. We say that all the time in the gas turbine programs and generation at EPRI, that's our motto, trust but verify. we're not out here to prove something wrong. We're out here to try to make sure that it's right. And so it's not that we're taking a negative stance on anything. It's just trying to make sure that that we can truly trust what is there. So as we continue on here, again, if you've got other comments, I'd love to see some biggest challenges that you are facing or you think the industry's facing that you can put in around digital twins. You know, even from just understanding to some extent, depending upon where you're at, understanding what a digital twin is or is not, you know, that's somewhat ambiguous. I've heard digital twins be referred to anywhere from the full emulation that I think that we hope for, all the way down to just a blue light or white light scan of a part. And while there may be some validity to it is a digital representation of the asset, there's got to be some other analytic aspects to that digital twin as well. But, you know, also, what task would be most valuable to you if they could be taken off your plate by digital twins? I think that maybe falls into if there's something that could be, you know, taken over by digital twins, giving you those insights. What would those things be? From a big picture standpoint, what would you like to see digital twins assist with in the future? And so I know we got another comment here, or question here. How far can we take digital twin? Can we have digital twin for Mars rover or space station? You know, that's a great challenge and great question. And ultimately, I think as far as at least thinking about from a power industry standpoint, how far can we go? How far is the right way? I don't know, Wesley, do you maybe want to give your thoughts on how far can we go or should we go?
Wow, that's a tough one to answer. You know, because I think it's just the maturity level, especially in just in power industry in general, let alone nuclear, is just, it's so new that I don't think we have an idea till we start really implementing more and more and seeing where we're getting. But I can tell you, you asked for kind of the biggest challenge, and I'll try to tie that back into it, is for us in nuclear, it's really about reducing O&M costs. I mean, whether we like it or not, nuclear isn't in the 70s what they thought it was going to be to operate, and we continue to run into those challenges. It seems like it's cyclical, especially since I've been at corporate, that, you know, every couple of years we have to reevaluate where we're at and either implement new products that help not necessarily reduce people, but reduce workload, or in the end, you know, cut the amount of people doing it. So I think our biggest challenge is, you know, and it's from a business case standpoint, is if we're to implement a digital twin, it has to be something that we can put on paper that's going to save us money in the long run. And a lot of the things that we're implementing now, we've gotten that approval to do, whether it's thermal performance sensors that we're installing across the fleet right now, so that data is coming into the M&D center and that can be monitored from one location. And those thermal performance engineers, like you said, Bobby, they can spend their time on the things that are more important to be working on. Same thing for some things we're looking at with data coming in to the M&D Center for condenser health and integrity. You know, I own that program in chemistry. We always had a good program for how to address it when we had condenser issues and for how to monitor it offline, but not a lot of things to help us predict and better operate and stay ahead of possible issues with them, with our condensers. So I think in the end, I can't narrow it down to say, hey, this is how far we would be willing to go. I think a lot of that is going to be tied into the projects we implement and just seeing the benefit of it and it growing from there. We haven't really done much outside of what I'm referring to right now as far as bringing data in and using some AI to help us with monitoring and diagnosing things.
Yeah, and as we think about things, one aspect that I kind of want to maybe focus a little more on is really thinking about the difference in an actual digital twin versus just M&D and data monitoring in general. And I think that there may be some gray areas, and then there may be some very distinct differences. I mean, first of all, digital twins are more than just monitoring for differences or anomalies. Really, the digital twin is there to replicate, to emulate, and to give you additional insights. And I think really, as we think about things, there's, yes, this fits into what M&D centers do. This fits into, data monitoring, but it's, a great enhancement and next step from just looking at data in general. So, ultimately, there's a good point to be made that data monitoring with AI is not a digital twin, and that's definitely a good point to make. And the reason being is it kind of goes back to a comment that I had made earlier, in that we've tried some AI capabilities with certain data sets, and really that's going back to, I think, a comment that was made earlier, is that yes, there's an opportunity to try to do some automated understandings and things with AI, but if you don't have physics really baked in with the digital twin itself and a framework set up, you're simply just doing an AI activity. Now, is there anything wrong with that? No. But just the distinction of making here that digital twin is a different mindset, a different setup. So I don't know, Wesley, any thoughts or comments around those thoughts?
No, and I just wanted to say I didn't want to make it seem like I was leading us down that path. If I did, my intention there was to say, hey, we're already doing those things. It is time for the next level approach. I don't know how far we want to go with it until we really start to dip our toes into the digital twin and show that there's at least one area where we can see how that leap from just standard bringing in data to a central location and plugging a little bit of AI on it, taking that leap to digital twins, what it can do for us. So it's hard to answer that question, but yes, I couldn't agree more. There's a huge differentiation, and I think that's why this was kind of one of the things that, when I sat down for performance goals for the year, we wanted to make sure that we got as engaged as we could over 2021 with digital twins to start getting an idea of where and at what level we could implement something, so we can start to get a feel for it within our industry. And I'm sure the same goes for the gas turbine side of things. You really got to walk or crawl before you walk, right? So we have to find something that'll work for implementation's sake to get that ball rolling. And I know it'll happen. It's just a matter of taking that leap. But if you asked 10 years ago if some of the things that we're doing now, if we could ever foresee doing that in the nuclear industry, people would have said, oh no, they're never, we've always done it this way approach, we're never going to go that way. But that's not the mindset of the industry, and definitely not Southern Nuclear. So I think, yeah, you're exactly right. I'm just looking for what we can do to get that next level, because to me it is a big leap from what we're doing now to bring in real digital twin technology. Yeah,
absolutely. And I guess we got a couple comments and threads being put in that I want to address, and I know we've got about 10 minutes left or so. And with that, let's see. So it is a significant investment that requires the identification of a return on investment. It does require that it is right when implemented. There's a bit of a leap of faith required, and that is definitely true. I mean, as we think about how far we can push digital twin, we can paint a very big, broad picture that says digital twin can, solve world hunger. and that we can do anything and everything with our digital twins. But in all honesty, we really need to be thinking about how do we package what we're trying to do in a way that we can have actionable off ramps. In building a digital twin, are we really, I know for a gas turbine, we don't necessarily have an end in marker to say once we get to this point we're done, because we feel like it's kind of taking the building blocks one at a time. So we've got a roadmap that has off ramps of trying to do A, B, C, D, and as we continue to do A, B, C, D, maybe that affects the next off ramps and we look at things differently. But ultimately, I think one of the challenges for us is to have proper off ramps for each of these activities so that we can show proper return on investment. And sometimes that may be difficult. Sometimes these digital twin outputs might be for things that maybe happen once in a lifetime for a unit, and you're just trying to avoid that. And there's, not everybody buys into that being part of your return on investment. So there's definitely challenges there. So I think a lot of it's how we package and really set up our milestones for accomplishing things. And, digital twins, can this accelerate the replacement of conventional manufacturing design with additive manufacturing, lower cost options? So I know that from that standpoint, yes, there's a lot of work going on. I think for this conversation, we may steer clear of looking at that, but there's, making just a small part, you could be multiple football field lengths of welding essentially for making additive parts. So yes, I know digital twins are heavily used there, and for those processes. ASME's done a lot with their digital twins and specifically looking at additive manufacturing. But what about using digital twin physics to bound AI, machine learning, and or inform layers in neural networks? And I definitely think that that's kind of the crossroads that we're looking at for enhancing what digital twins can do. Wesley, any thoughts or comments around that question there?
No, I would agree with that. I think that's where it's going to help us, is building the layers into it as far as how far we look and consider the data and how we use it, or how we consider that, so what we do based upon the outputs of a digital twin. Let's put it that way. That if it can help bound and add layers to it, then that's the more the better there.
So I think as I look at some of our topics today, some of the themes, I'm going to throw out a few challenging areas that I'm starting to hear that's repeated over and over again. First of all, verification and validation. Looking at those aspects, I think that is a great challenge with any sort of software analytic process, but especially for digital twins, because there's so much going on with the way these digital twins work, and we really need to know, are we asking a digital twin to do something that it's not capable of? And specifically, if you're starting to look at something that's very black box like, which most of these applications tend to be, you really need to know what really can be performed with these. So I think that's a big theme that I'm hearing. Another theme around data, there's the data availability, maybe thinking about what is possible with data streams that you have. But also, I would like to pose this challenge and see maybe if there's input here as far as how do we properly simulate data, whether it be good data, bad data, and what I mean by bad data, essentially faults. How do we simulate faults? How do we simulate good behavior for units that either do not have the proper instrumentation. Maybe they're new units. I know that there's things going on within the industry for new assets being developed and trying to use simulated data to start digital twins for those assets. I think there's great challenges. How do you trust that? It kind of goes back to the verification and validation aspects, but how do we, come up with a proper way to make this this simulated data? And I'll give you an example for gas turbines, how that we've tried to use our digital twins to simulate certain faults, like I mentioned earlier, where there may not be, data within the industry to show these particular failures, or maybe you as a utility do not have access. How do we properly simulate those so that we can maybe train APR software, so that we can train other digital twin capabilities? So those are kind of two big themes that I'm starting to pick up on in the last few moments here. If there's a theme that you have that really we need to have this kind of AI digital twin advancement, we need here's my thoughts. Pop them in chat. Wesley, as we finish up, any final comments that you would like to make, or challenges to our audience?
No, I just last final thought is just that I couldn't agree more with what you stated there, in that again, we don't have a narrow focus on what it's going to look like. We're just looking for opportunities where we can get this ball really rolling, and we want to be on the forefront of it if we can at Southern Nuclear. But I'm sure the same goes for you, Bob. You just want to get something down on paper so that we can prove the worth of it, and kind of go from there. And we just, we've done that with lots of technologies over the years, and I think this is its time to take the step with digital twins.
Absolutely. And I like the comment there from Henry: open collection of data from failures for validating digital twins. I know, again, EPRI's putting together our top 10 data sets, but maybe it's branching out further for some of these that we need more for the challenging of how to simulate degradation when we haven't measured it. One can consider the method of multiple working hypotheses, and then let's see, gets a little bit into decision science sorts of topics, also similar to constructing a credibility assessment framework. So great thoughts around this. I know we have just 2 minutes left. I've put my email in the chat further back. I'll go ahead and put it in here again. If you've got any other thoughts or comments, questions after the session, feel free to share them, and I can make sure that Jeremy gets those and we can collect those together. But I definitely appreciate everybody being on. We've had great participation throughout the whole time. Again, we've got another couple moments that if you have other thoughts or want to make any last comments, feel free to raise your hand or put those in the chat. But I really want to say that I've enjoyed this week, and getting to hear what's happening in the AI realm from others around the industry. And this has been a great exchange of information and ideas, and so definitely appreciate everybody being active. So
yes, thanks everyone, and thanks Bobby for leading us.
Hey, absolutely, Wesley. Thank you. Also thank Josh Berry for participating on Monday as well in our reverse pitch. And so we look forward to continuing these discussions even after this week is over. And thanks everyone for joining today. And with that, I think we're right at time. So I guess we will sign off for now. And again, if you've got any questions, feel free to shoot me an email or other comments.